It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer. A challenging GATE contest engineered to give you an experience like none other, where you put your knowledge to test and battle it out with the best. To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for the field day, with the best of the questions by best educators, with detailed video solutions from top educators right after each contest. Combat live with peers to get real-time rankings and win big. Participate in every contest to improve your rating. Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Hello students, very good evening to all of you. Myself Rajeev Singh. I'm a plus educator on Unacademy platform, and as you saw, this combat is going to start, combat test 3. That is there on 16th. You can enroll there. While enrolling, you need not to pay any fees. This is a free test series, and in this test series, we guys, myself, even have given some very good questions that will test your knowledge. These questions are there along with the video solutions as well. Once you go for the test and you complete it, you get some rank. There are prizes for that as well, and by the end, when you want to see the solution and answers, very nice and deep solutions are given. So I would ask all of you to join this. Now let us start today's session, that is there on gas welding. First I will brief you on this gas welding process, and thereafter I will let you know about these previous year papers as well. Okay, let me just first upload the question PPT that I have. Hold on for a minute. I've just downloaded it. Okay, let me have it at full screen. Yes. So last class में हमने arc welding पढ़ लिया था, right? In the last class we had learned about this arc welding. I hope I am clearly audible to all of you. Yes, great. So देखो, what happens in gas welding? Actually, you will have a cylinder. Let me show you that. Like here. Here there will be one oxygen cylinder and one acetylene cylinder. That oxygen cylinder will be made black in color. Okay, here right now if you look at this is the oxygen cylinder. This will be made black in color. Okay, and if you look at the acetylene cylinder, then the acetylene cylinder will be made red or black in color. Moreover, the oxygen gas is stored in this cylinder, and this cylinder will be made out of what? Brass. You cannot make the oxygen cylinder which is made out of what? Steel, because the problem is if you made it out of steel, it will corrode and the life of cylinder will be too less. So instead of making it of steel, it is made out of brass. While this acetylene cylinder will be red in color and it will be made out of steel. You cannot store the acetylene gas into the brass cylinder because acetylene in itself is highly flammable and explosive. And once you store it in brass cylinder, where it will react with copper will form cuproacetylene, which is further very highly explosive in nature. So dear students, this acetylene cylinder, which is made red in color or maroon in color, is made out of steel, and that oxygen cylinder here is made out of brass, because oxygen if you store in what? Steel cylinder, it will corrode it and the life of cylinder will be very less. Moreover, how do we get oxygen? Oxygen is actually filtered out from the atmosphere. We take the atmospheric air, we first do the cleaning so that we can remove all those small impurities and particles, dust, everything from it. Thereafter, we heat it in a chamber. Once you heat it, then what will happen? The lighter gases will go on the top The heavier one will come in the bottom, and then one by one the valves will be opened so that lighter gases go out, heavier gases go out, and we are left with the three gases which are argon, nitrogen and oxygen. Now, these gases are sent into a compressor. In that compressor, it is compressed a lot. Once that compressing part is over, then the gases are intercooled. They are cooled a lot, and then they are throttled. Once you do this throttling, you will get the liquid nitrogen, liquid argon and liquid oxygen. Out of all the three, oxygen will have the highest boiling point. So now this liquid mixture of nitrogen, oxygen and argon will be heated in a controlled way, so that at first nitrogen evaporates out, then argon evaporates out, and you are left with liquid oxygen, which will be stored inside this cylinder. How to get the acetylene? To get the acetylene, we take calcium carbide, we react it with the water, and that reaction results into the formation of acetylene gas. But problem with acetylene gas is acetylene can explode under its own weight. So acetylene cannot be stored directly into the cylinder, my dear. No, you cannot store acetylene directly into the cylinder. For that, you know what we'll have to do. At first, that cylinder in which you are going to fill the acetylene gas under certain pressure will be filled with porous calcium silicate. Porous calcium silicate. Into those pores, acetylene gas can enter, so that all the gases will not be at the same place, so that they will explode, right? And then the remaining space is filled with a liquid called acetone, and then acetylene gas is filled into it at certain pressure 1.3, 1.4 megapascal, while the pressure into this oxygen cylinder can be like between 12.7 megapascal to 13.8 megapascal. And moreover, acetylene is always stored in liquid form, because if you are storing it into liquid form, more volume can be accommodated into the same cylinder, right? This is the setup. Now what happens? You will have these pipes coming out from these cylinders. You saw, see, this is the oxygen cylinder, right? From here, from the oxygen cylinder, a copper pipe will come out, and then from the acetylene cylinder, a rubber pipe will come out, and both of these pipes will go into this welding torch that I have shown you here. This is the welding torch. Okay, you see, my dear, here these threads in which these hoses, these pipes are being fitted, they will be also different. Because suppose by mistake this copper pipe fits into this what we say acetylene cylinder, then acetylene will react with copper, it will explode. That can be very much fatal for the welders. So American Gas Society, there is a society there who learn about all these compressed gas, American Compressed Gas Society. They decided to change the threads, because left hand thread will fit with right hand thread only, or right hand thread will fit with left hand thread only. So suppose if we are here making the left hand thread onto the oxygen cylinder, this pipe will always have right hand thread, and this cylinder will always have right hand thread. So right hand thread can, by mistake even you cannot fit it, so that will be safe for the welder. Otherwise the explosion can even result into the death of the welder or the persons which are surrounding it, right? Are you getting that? Chalo, this is the setup. Now what happens, my dear? You will have this torch. In this torch, from one side this oxygen gas will come, and from another side this acetylene gas will come, and here you can see the chamber. This is a mixer. This will be like a chamber with diverging type of shape, not converging type shape. Divergent shape will be there, so that pressure increases and mixing occurs thoroughly, and then this mixture will pass through here, and here at the tip it will be like convergent type. Why convergent type? Because now under the expense of pressure, that mixture of acetylene and oxygen comes out at a higher velocity, and then you can simply light it and you will have this flame. Now if you look at the flame, my dear students, the flame can be like visualized like this, the flame that is there in front of you. Here there will be this inner cone of the flame, and there it will be the outer cone of the flame, my dear. You see, when these gases come out, my dear, the mixture of acetylene and oxygen, then you know what happens? The acetylene gas burns in the presence of oxygen into two stages. What are those stages, my dear? Let me show you. Here, in the first stage, what happens? This acetylene gas burns in the presence of this oxygen, which has actually been supplied from the cylinder. This oxygen gas is the one from the cylinder. In the presence of this oxygen from the cylinder, the CpO2 burns and produces this carbon monoxide and hydrogen gas. Okay, and plus this heat is generated, and this burning results into formation of this inner cone. Okay, and then what happens, my dear? In the second stage, this 2 CO plus O2, this forms carbon dioxide, and hydrogen and oxygen, they form water vapor and then heat. So this is the second stage reaction, and here whatever oxygen is required, my dear student, that oxygen is actually obtained not from the cylinder. That oxygen gas is actually obtained from the atmosphere. What? Second stage. And the second stage reaction, my dear students, results into the formation of my dear, this outer cone. Right? Now, my dear, the temperature at the inner cone here and the outer cone, how much is the temperature? That will depend upon the ratio of the acetylene and the oxygen that you have used. Suppose, my dear, if you are using same amount of oxygen and same amount of acetylene, yes, 1:1 ratio if it is there, then this type of flame will be called as oxidizing flame. Sorry, neutral flame. Because since enough amount of oxygen is there and enough amount of acetylene is there, both are equal in amount, so there will be no extra carbon or oxygen after the reaction completes. Once that happens, my dear students, that type of flame, which we call as a neutral flame, will never carburize the region being welded nor oxidize the region being welded. So this will be like the one flame which will be preferred mostly. And in case of neutral flame, the temperature at the inner cone will be about 3100 degrees centigrade, while the temperature at the outer cone will be about 1275 degrees centigrade, my dear students. Yes. Now, suppose in case the O2 is more and C2H2 is less, this ratio is greater than 1. Then this type of flame is, my dear students, is what we call as oxidizing flame. This is what we call as oxidizing flame. In case of oxidizing flame, what will happen? Oxygen will be more, steam will be less. Reactions will happen at faster rate. This inner cone length with respect to, as compared to the neutral flame, this inner cone length will also be very small as compared to neutral flame or carburizing flame. This flame will be neutral flame, sorry, inner cone length of this flame will be lesser than that of neutral flame or the carburizing flame. Why? Because more oxygen is there, burning will happen at higher rate. So cone length, inner cone length will reduce, and since it is happening at very high rate, right? So the temperature at the inner cone will be the highest out of all the three flames which are carburizing and this neutral and oxidizing flame. And here the temperature can be as high as 3300 degrees centigrade to 3400 degrees centigrade, while the temperature at the outer cone will be about 1350 degree centigrade, my dear students. Now what happens? In case if oxygen is less and acetylene is more, yes, so this ratio is what results into, we call it carburizing flame. In case of carburizing flame, my dear friends, what will happen? Undoubtedly the length of the inner cone will increase, yes, and even some internal cones can form, because you see oxygen is less, burning will not happen perfectly. So apart from the inner cone, some extra cone may also appear. I am not saying every time it will appear, but may also appear. The length of the inner cone will be the highest as compared to anyone. And one more thing, my dear, the temperature will be the least, because oxygen is less, burning will happen at a very slow rate. So the temperature in case of carburizing flame will be the least out of all the flame, highest for oxidizing, and in between there for neutral flame. The temperature at the external exterior cone is going to be equal to about 1200 degrees centigrade. It can be even lesser than that. Now, this was all about the gas welding. I have given you the overview of gas welding in a very perfect manner. Ratio between oxygen and acetylene gases for neutral flame in gas welding is equal to, you see, in case of neutral flame, what happens? The ratio will be like 1:1. Yes? Now, let us take the next question. Just a minute, dear. Hold on for a while, just a minute. Guys, I'll take just a minute. Huh? Yes, now let us take the next question. Yes, by which of the following method grey cast iron is usually welded? Remember, my dear, grey cast iron is welded either by gas welding, or there is one more process with which the grey cast iron is welded, that is braze welding. Okay. Now, they are saying in gas welding, the metal to be joined gets oxidized or carburized. The neutral flame affects no chemical change on the molten metal. You see, in gas welding, yes, the metal to be joined gets oxidized or carburized, but do you think always it will oxidize if the flame is oxidizing? It will carburize, the surface will carburize, more carbon will be enriched there, surface will be enriched with more carbon in carburizing flame. But what if it is neutral flame? Neither oxidation, no carburization, means no deoxidation will take place. So my dear, or no decarburization can take place. So my dear, this statement is only true for oxidizing and carburizing flame. This statement will not be true for neutral flame. Yes, so a statement becomes wrong, and once the statement becomes wrong, answer becomes D. You all know about assertion region question, but though, let's look at the statement 2. The neutral flame affects no chemical change on the metal. Yes, true. It will neither oxidize nor carburize. So yes, statement 2 is correct, and we will have the answer as D. Yes, chalo. Consider the following statement. They are saying for oxygen welding, the joint is not heated to a state of fusion. No, the joint is heated to a state of fusion. By the way, what are they saying in the last? Which of the above are correct? This is incorrect. No pressure is used. Yes, this is correct. This is a fusion welding process. Remember, in arc welding and gas welding, we don't use any pressure. Where do we use pressure? Resistance welding, we use pressure. Friction welding, we use pressure. Ultrasonic welding, you use pressure. And by the way, arc welding and gas welding, we use only heat. Arc welding and gas welding, we use only heat, no pressure. Now, both heat and pressure in what processes? Friction welding, both heat and pressure. Ultrasonic welding, both heat and pressure. Resistance welding, both heat and pressure. Now, if I ask you, can you name any process in which we don't use any heat, we use only pressure? Yes, that process is explosion welding. In explosion welding, no heat is applied or no heat generates at the interface of the two pieces which are being welded. Only pressure will be there, and yes, welding occurs due to interlocking of the metals with each other. Yes, that is a different process. By the way, this statement second is correct. Oxygen is stored in a cylinder at a pressure of 14 megapascal. Yes, I told you 12.7 megapascal to 13.8 megapascal, which is very near to 14 megapascal. That statement is correct. When there is an excess of acetylene used, there is a decided change in the appearance of the flame. Yes, by changing the proportion, by changing the ratio between oxygen and acetylene, yes, the appearance of the flame will change. Yes, my dear. So this statement is also true. Let us find where is 2, 3, 4. 2, 3, 4 are correct. So answer will be B. Great to listen from all of you. Great to listen that from all of you. Now, where is the other question? This one. This didn't upload exactly actually, but no problem. The one question that was there, if for complete combustion of, the question is that I was about to discuss, if for complete combustion of acetylene, how much oxygen is required? How much oxygen is required? What will you answer? Anyone? I can see you in comment section. For complete combustion of acetylene, how much oxygen is required? Sound is not clear. Who is saying that? Cedulam is saying that. Let me see. सही से आवाज आ रही है? Okay. Okay, in the comment section I am waiting. I am waiting in the comment section. For complete combustion of acetylene, how much oxygen is required? Or let us say for complete combustion of 1 liter acetylene, how much oxygen is required? You would have done this in chemistry in your 11th and 12th year. Anyone? और इस क्वेश्चन को थोड़ा सा और अच्छा बना सकते हैं, अगर चाहो तो ऐसे बना सकते हैं, रेशियो बिटवीन acetylene and oxygen for complete combustion. For complete, combustion. I'll also give you the options, okay? I'll also give you the options. This is like option number A, 1:1. Option number B, 1:2. Option number C, 2:1. Option number D, 1:2.5. Now, can you come into this comment section? I am expecting some answers from all of you. 1:2.5, 2:1, 1:2, and 1:1. Anyone? No one. 7 of you are live and no one is answering this question. Actually मैं क्यों क्वेश्चन करवा रहा हूँ, क्योंकि मैंने बहुत सारे जो ये पीपीटी पीडीएफ जो लोग बांटते रहते हैं ना, फेमस हो गए हैं, उन्होंने गलत आंसर लिख रखा है ना, और एक्सप्लेनेशन भी गलत दे रखा है, इसलिए मैं बोल रहा हूँ ताकि आप कंफ्यूज ना हो जाए। तो मैं जानना चाहता हूँ। यस, ग्रेट सैदुल आलम, ग्रेट ग्रेट। तुमने क्या किया? C2H2 plus 5/2 O2. This reaction is going to produce what? This 2CO2 and plus H2O. Yes, I hope this reaction is balanced, and you all know that what happens, molar mass and volumetric mass ratio will be same. You know, here 1 mole requires how much? 5/2. 5/2 is what? 2.5. So the answer will be D. Yes. So with this, my dear, your gas welding completes. Let's meet tomorrow sharply at 8:30 for the next topic. Already the sections have been created, and moreover, if you are using Unacademy for special classes, you can come. I am taking daily 4 classes for upcoming exams and making you practice the objective questions. for UPPSC and RINL as well as for GATE. So my dear, if you want to join those special free classes, come join. If they ask you to use any referral code, you can always feel free to use the referral code RK007 either to unlock the free class or to subscribe so that you can have maximum discount. So guys, thank you. Thanks for coming. Let's meet into the next session tomorrow, same time, 8:30.